Welcome back. This is Chapter 2 of the Beginner's Guide to FreeCAD. This video has a slightly different focus. We're going to be doing some modeling as in last video, but we're also going to be focusing on viewing a lot of the add-ins and other functionality that is available to FreeCAD users. And that makes this video not necessarily a complete end-to-end video with every tool explained as before, but a look at what can be added into FreeCAD, how to add it in, and what the workflow looks like. And I have more detailed videos uploaded to the channel if people have more questions on how to use these additional tools that I'm going to go through. I am reminded of when I started this channel. It was because I was frustrated I was not given good sources of CAD to learn at university. This value of making information accessible and free has become very personal. And that's why I'm so happy to introduce today's sponsor, Brilliant.org. Brilliant offers numerous courses to take and is available for anyone who wishes to improve themselves. The Python course is particularly interesting to me. While a lot of courses go through rote code writing, this course is careful to animate and truly help visualize concepts. But it isn't just animations that make a difference. The interactivity is integral in Brilliant's approach. This is true for all of Brilliant's courses, as the interactivity is truly key. While it is possible to read a book and learn, the interactivity of Brilliant speeds up understanding of important concepts and makes the topics truly come alive. Brilliant offers classes in logic, mathematics, statistics, science and scientific thinking, and even programming in computers. For these reasons and more, I'm so excited to work with Brilliant. No matter your goals, I think there's something here for everyone. Please see my personalized link in the description, and the first 200 subscribers will receive 20% off their subscription. But first, let's start off by building some more skills with the not part design workbench, but part workbench. So we'll come back here and take a look at what the part workbench has to offer. I'm going through the part workbench, and I'm going to go through it in a good amount of detail because part is so important on tying a lot of the other features that FreeCAD has to offer in, and a lot of ways to add different things and different add-ins for FreeCAD in is kind of through the part workbench. So we're going to get a good idea of what this workbench is and how to use it. You'll notice first off, out of all these tools, there is not a button to create a sketch. And if we head on over to part design, right, we probably recall this is pretty easy. We just click the sketch button, we select our plane, and off we go, we're in a sketch. But if you notice, we're not in part design anymore, right? We have this workbench called Sketcher down here. So when we click the sketch button in part design, it actually takes us to a different workbench that is specifically for sketching. I'll delete everything in my tree here. So when we want to make a sketch in part design, we actually just go to the Sketcher workbench, make our sketch, and then manually go back to the part workbench and use the sketch in the way that we see fit, which I'll show as an example in a few minutes. As of right now, let's take a look at some of the first options that we have in the part workbench. These measurement tools probably look familiar because they're the exact same ones in the part design workbench. So I'll skip those. We went through those in the last video, at the very end of the last video if I remember. And I can go ahead and start creating what we would call primitive shapes, right? These are pretty cool. In fact, I'll get rid of my cube for now. Let's delete that. So I can create these shapes, and when I go to my cylinder, right, I can either right click and say edit cylinder or just change some of the properties down here. I might want to change my height from 10 to 20, or take my radius from 2 to 3, right? I can do whatever I would like. I'll take that back to 2. But I can also reposition this, and I can reposition this in several ways. I can go to my placement and my position, and I can look at my z-axis, right? You can see my z is pointed in the positive direction. So maybe I want to move this down. That would be negative 10 millimeters in the z direction. And that moves it down. Likewise, if I want to try a different method, I'll show by copying and pasting. I can copy my cylinder and I'll just hit Control V and paste my cylinder in, so I have a new cylinder now. And here I can edit my cylinder, and I can open this up for a little bit more view if I need. And I can take my rotation, right? Right now there's a 1 value in the z-axis, so I'll put a 0 value in the z-axis and a 1 value in the y-axis. And now I'm rotating around my y-axis instead of my z-axis, so whatever has the 1 value is the axis that it rotates around, and I'm going to say 90 degrees, right? And then I can reposition this to say 0, and I want this to move in this direction, so I'll look at my x-axis, and I'll say -10, and now I've got this sorted out, right? So I can rotate and move things in this way. In fact, I'm going to hit Control C and Control V again, and I've just copied and pasted this cylinder. I'll edit this cylinder now. We're going to say 0, and instead of my y-axis, I want to rotate this around, say my z-axis. Actually, no, my x-axis. So I'm going to put a 1 on my x-axis, and then maybe I want to move this in the y direction, +10. And I've made this kind of mine-looking thing. Kind of reminds me of this toy that was on the market when I was growing up. Kind of a cool one. I've never had it though. Anyway, let's grab a sphere, or a cube rather. It's actually kind of late at night, so I'm gonna say I'm saying the wrong thing because it's late at night. We're gonna make this, how about 4, 4, and 4 in size, and we'll make this actually 8, 8, 8, 8, and 8. That's better. And then we'll move this. How about -4, -4, and -4? So now I have all these parts that are taking up the same amount of room, right? So I'm going to hide my cube for now, of course, with the space bar. And so when the part design, or I'm sorry, the part workbench rather, uses CSG, constructive solid geometry, if I remember that acronym right, and CSG modeling. You'll notice we don't have something to remove material, right? We have extrude right here. We do not have extrude cut. So how do we remove material, right? That's an important one. Well, here's how we do it. First off, we'll select our sphere, and we're going to say this is the body that we want to remove material from. And I'm going to hold Control, and I'm going to select this first cylinder. And the second thing that I click is the body that we want to remove from our cylinder, right? This is just like the multi-body modeling that we've done in the part design workbench. And I come over here and it says make a cut of 2 shapes. Click that, and we've removed that body from the other one. Again, I can choose my cut, choose my cylinder, remove. Again, choose my cut, choose my cylinder, remove. So I've removed my cylinders from my body. Likewise, I have my cube right here. I'll show it again with the space bar. Maybe I want to have a common or an intersection between these two. So I select both bodies, run an intersection, and there we have our resulting solid. So this one here is to make a union of several shapes. So these are pretty fundamental: cut, union, and intersection. And these sort of take the place of ways that we might traditionally add features. So we work with the part workbench pretty much exclusively by using these multi-body modeling tools, which is CSG modeling was the modeling that was used in very old school CAD systems. So part workbench is much older than part design workbench in FreeCAD, and that age difference starts to show because we're using sort of an older CAD modeling technique in the part workbench. Nonetheless, part is still fundamental and relevant in the modeling workflows that we use. So it's a great workbench, and there's still updates being made to this workbench in FreeCAD versions, so it's useful. I don't think it's going away soon. Nonetheless, we can use sketch-based stuff to work. So let's do a few examples where we use the sketcher in the part workbench. Now I've accessed the sketcher. Let's sketch on our XY plane. Let's say I want to make a big giant circle. Of course, you can't really see the sketch, so I'm going to switch between section and full view. Shift R is a hotkey that performs a radius, right? So I hit Shift and R, and then I click on the circle for my radius, and we're going to go with 3.5. How about? We'll close, and then I'm going to switch back to Part, and I'll choose Extrude, and it asks me about my parameters. I can go symmetric if I wish. I can go down 10 millimeters, right? So I have all these. I can reverse the direction if I wish, but I just like this for an example, so I'm going to say OK, and it creates my extrusion for me. Now you can see that these parts are not, they're separate bodies, right? So I have one body here, one body here. I couldn't put a fillet on this edge because they're separate. I can't, there's no edge between there because there are two bodies taking the same space. They're not merged. So I can hold Control and choose these bodies, and I can merge these together if I wish. And I can do that right here, make a union of several shapes. I'll hit Control Z just to undo what I've done. Select them both again. So might as well look at this button. This is just a way of having, you know, all of your options available if you wish to run it this way. I have my union selected. If I say apply, same thing happens, right? It's just that's a more involved way of working with the multi-body modeling commands. So we've done a union, we've done a cut, and we've done an intersection. I'm going to actually get rid of my fusion. So that's an example of using a sketch with an extrude. We'll delete that. Now I also can fillet. So let's take a look at that. I select, how about this edge, and I click this little fillet button right here, and I can select as many edges as I wish. And just like in part design, I can select my radius, which I'll leave at 1 millimeter, and I can do it by faces or edges, and I always wish to do it with edges. I get more control that way. And of course it asks me which body I want to apply the fillets to. This is my only active body, so I'll add that. As you can see, well, at least one fillet worked out. Let's see. Oh, I think it's because I somehow deselected my edges when I was too busy talking. So let me reselect these edges and make sure that we are all clear. So it looks like I've got my edges selected. Yep, we were able to fillet everything, so that's nice. Now we also have the option to, just like in the part design, add a chamfer. So if I come over here, add a chamfer, maybe I'll make this 0.25, and we're going to say OK, right? And there we've added a chamfer. So as always, I can edit my edges, and I can add more chamfers if I wish. Might as well do all the edges so that we look symmetric. See, and you can tell that my chamfer dimension reset. So these were all listed as 1 millimeter. I'll just retype in 0.25 there. All right, important detail when you edit these things. So we've got that worked out. Now let's take a look at our tree, because our tree is a little bit different. So as you can tell, I've got my sketch here from that extrude that I decided not to use. I can just delete that with the delete key. When I look at my tree, my whole body is called chamfer because that was the last operation I did on it. I open that up, and below that is fillet, And so if I show my fillet with the spacebar, and I hit the spacebar again to hide my chamfer body, you can see what I did before that. I open up my fillet, you can see I've got this little common body. So if I hide my fillet with the spacebar and show my common body, this is what it looked like before I filleted it, right? So you can see we're stepping back through the history of our part, but we're doing it in a different way. It's like there's sub-items. I come down here, and let's say I hide my common, and I show my cube, and I show my cut. You can see I'm just backing up through the history of how I've made this part. So I can hide my cube, and I can open up my cut, and I can show the components under that. So this is just a different way of recording the history of the part. And I'll go ahead and show my common right now and hide my cut and cylinder. So I can go to my very first sphere and my very first cylinder down here, and I can change my sphere radius to something like 6 millimeters, and my whole part updates to do everything as though it were originally 6 millimeters. And you can see my fillet broke up here because a 6 millimeter fillet on these edges, it just created a problem that it couldn't solve. So we can easily resolve that by changing this back to 5 millimeters, and we rebuild, and we can see our fillets are back again, fortunately, and our chamfers for that matter. So we can still update all the things that we've done, just like any other parametric model. This just takes a different structure to the history tree, where when we do Boolean operations and things, they show up as kind of sub-items, as you can see. So that is the part workbench as far as doing these combine multi-body operations, as well as like an extrude. We have Revolve, and that should be pretty simple, right? If I go to the sketcher and I create a sketch, and I'll do so on the XZ plane, and I'll make an off-axis circle. In fact, I could probably just get it so they overlap a little bit. We'll head on back to the part workbench. We'll create a revolve. We'll choose our Z axis and say OK. And there you can see I've created a torus. And I can take my chamfer and my revolve, and I can do a subtracting Boolean if I want to, right? Hey, that looks pretty cool actually. So lots of things that you can do with Revolve, and it works much the same as part design. It again is just focused on multi-body modeling. Every feature that you make is not merged or part of what you've already made. You have to do that manually. So we'll delete that. If I haven't mentioned it already, I guess I should redo that so I have something to show you. I can always reposition my bodies, not just with choosing the numbers down in here, but I can also right-click and transform. And now I can change the position of this however I wish, just visually. I can change my translation increment, so if I know I need to move it 20 millimeters, I can give it an increment of 20 millimeters and move it, say, one time. I was too zoomed in there. So I can move this in increments of 20 millimeters, or if I want it to be really smooth, I can say 0.01 millimeters. And I accidentally got out of there here. And now we're moving silky smooth at 0.01 millimeter increments. And same thing with your 15 degree. You can always change your increment from 15 to some other value. So let's delete the revolve now. So we have extrude and revolve, which should look remarkably similar to what we've been working with on the part design workbench. We can mirror a shape, right? So if I take my chamfer and I move this way over here, and I say OK, and I stand on my chamfer and I highlight this button, mirroring a selected shape, It asks me what shape that I want to mirror. These are all the shapes that I've made. And of course I'll choose my chamfer. And my mirror plane, how about my XZ plane? And I say OK, right, and I've made a mirror image. So if I were trying to make a pair of shoes, I'd have my left shoe over here and I could mirror my right shoe to kind of copy the body, right? Useful feature. So though that should work pretty well. In fact, I'll just Control Z it so I can get my original position there. And we've gone through fillet and chamfer. I'm going to skip this one for now. So now we want to talk about surfacing, lofting, sweeping, and all that. Right, the lofting and sweeping in part design is very much the same. So I'm trying to think about how best to do this. Let's go to the sketcher and create a sketch. And let's sketch on our, how about our YZ plane? Nah, XZ. And I'll create that. Now I know that I didn't constrain that. That is not best practice, so make sure that if you're being serious, you want to constrain this stuff. For Sketcher now, we'll go on the XZ plane again, but this time we'll offset it by, how about 50? And reverse the direction. Right, so now we're sketching over here. Maybe I'll make a tall version, and we'll close. So that with the part workbench, it works much the same, where I'm going to say, let's do a loft, and I select this profile and move it over here. Then I select this profile and move it over here, and I'll click Create Solid, and OK, right? So we've made a nice little loft in the same way that we would with the part design workbench, but in part workbench, it is just a little bit different of a workflow. The same thing with sketch. And if I delete my loft and I go back to my sketcher and I create a sketch, this time on my XY plane, so I'm looking down on it. And I make a straight line for a little while. Again, best practice, fully constrain this stuff. And then I'll take this point and this point, and I'll make them horizontal, and then tangent, so that they're connected together, and they're tangent with one another. And I make just a very generic, basic sweep path, and I close. And this is true with a lot of things in FreeCAD. You don't necessarily have to have your path and your profile touch or be centered. It's a very kind of luxurious feature. I can take my sweep right here, and I select my sketch, which is right here, and I move it into my sweep profile. I click Sweep Path, and I just click on my sketch and say Done, and OK. You can see that I've created a sweeped path. You'll wonder why it's hollow. We're going to get into that. So again, I go to Sweep, I grab my sketch, I can choose my sweep path, I can hold Control, and I can choose these two things and say Done. I can check on Create Solid, and we've created a nice swept solid. So what's the deal? We've done sweeping and lofting. What's the deal with this Create Solid checkbox, and why was that other part initially hollow? Well, let me delete this. And let's do, how about a loft? We'll grab a loft, we'll grab our sketch, and we'll grab our next sketch for the next profile. And I'm just going to not check Create Solid, and it's hollow, right? And you think, okay, well, say this part that I already have floating in the background here, I can measure, say, how thick it is from this face to the bottom face, right? It has a thickness. So how thick are each of these walls? And this is what we start getting into with surfacing, and is the next major skill that we're going to see when we use FreeCAD or pretty much any modern parametric CAD platform. Surfacing is a very important skill. So what are surfaces, when do we use them, and why? and let's run through a few examples. Surfaces are infinitely thin. So this has no thickness, right? This is an infinitely thin entity that we use not to produce our final model, but are just a tool to produce our final model. So you don't sit down in CAD and say, all right, I'm done. My end result is this surface, because surfaces are infinitely thin. They're not going to exist in real life, but they are useful for producing the parts that we wish to produce. Let's go through a little example. So I'm going to get rid of this entirely and get rid of this and this and this, and I'll save my example part here. And let's start a new part focused on surfacing. From the part workbench, let's get started. I want to say make a sketch. In fact, you know what? Let's just show something real quick in part design. I'm going to create a sketch here, and I'm going to make an arc, and let's close that. And if I try to pad the arc, I get a failed to validate broken face error, right? So if I try to pad something that isn't closed, then I get an error. And of course, the way to fix that is to simply close the profile, and if I go to pad that, right, it pads no problem. So with that in mind, we're going to compare that with the part workbench. And from part, I want to go to Sketcher. Let's create a sketch on the YZ plane. And I want to make something that looks like the top of a computer mouse. And let's do that how it might look from the side. So Shift R to give a radius. We'll give that, say, 25. We'll select this point, say Shift H, which makes a horizontal dimension. We'll make that, say, -50. We'll select these 3 points, and we'll say horizontal, right? So that looks kind of like a computer mouse from the side. We'll close that. I want to make another sketch now from the XZ plane, and we'll make a single arc. I'll select the coincident and choose the body of the arc and my origin. We'll choose these 2 points and say H for horizontal. We'll select these 2 points and say Shift H, which gives us a horizontal dimension, and we'll say something like 50. And then we ask, where are we not constrained? Shift R to give a radius. Let's give this a radius of 75. All right, so we've got these 2 sketches. Now, if we try to work with these sketches that neither of which are closed, are we going to get a broken face like we do in part design? Let's head over to part. We'll choose a sweep right there. We'll choose our profile as sketch 001. We'll choose our sweep path, and I hold Control and select both of my sketch elements, and we'll say done and OK. And we don't get a fail to validate broken face, but rather we get this nice surface that is infinitely thin. So one lesson learned is where part design generates only solids, part can generate solids and surfaces. So we take this sweep, and the beauty of this is it's parametric. I would like to actually change this from, how about 75? Let's go down to 50 to really emphasize the curvature better. Close that, and that looks like a nice curvy surface. Next, let's use this in action here. Let's go to the Sketcher, create a sketch, and we'll choose the XY plane. From here, I'm going to make a slot shape. We're going to pretend like our mouse is a slot shape, even though that's a very boring shape for a mouse. We'll just make sure that the sketch lies within the bounds of our surface, but I won't fully constrain it in the interest of time. Again, best practice is fully constrain everything. We'll head back to our part workbench now. We'll choose Extrude. I'll choose something like 50 millimeters, symmetric, OK. And there we have a solid, right, because I do have my solid set to true here, going all the way through my surface. When that happens, we've got this interesting tool here. If I come down here, I can choose Slice Apart. Of course, I have to have two objects selected, so I'll choose my Extrude and my Sweep. And in that order, Extrude and Sweep, right? Because we always select the thing we want to use first and the tool second. I select Slice Apart, and I actually end up cutting my solid into pieces. And I can select either piece from this little folder in the tree. I'm going to delete Slice 1, and I have what looks to be something a lot like a computer mouse. It would look a little bit better, of course, if I maybe cut out this profile here and made it a little bit more curvy. But for intents and purposes, I was able to generate this curvy surface on top of my mouse quickly and easily with a surface sweep. Imagine trying to loft this. You couldn't do it in one operation because you'd have to start at this like infinitely thin front and move all the way to this infinitely thin back and cover, a loft you have to control every surface all the time. It would be so hard to make this otherwise, but we were able to make it quickly and easily here in FreeCAD. So that is one way that you can use surfaces, right? You can make one surface at a time and apply that to a solid rather than having to try to loft or sweep something like this, which would be so difficult. You could do it. You could make it work, but you'd have to do it in multiple operations, where this was kind of clean. So I'm going to hide my sketches with the space bar. And what else can we go through that would be useful? I'm going to save this first of all. And let's talk about a few other surfacing tools that are quite useful for making something like a mouse. So this is an example of a mouse made with only surfacing tools and then has been converted into a solid after it was made. It looks a little bit newbie, right? I kind of made a little bit of funny dimensions in there, but you can get the idea of what I was going for and how powerful it is to be able to make one surfacing object at a time. So let's break this down a little bit. I'm going to delete my fusion, my fillet, my solid, my extrude. I'm going to delete a bunch of surfaces that I have in here. So we get down only to the sketches. And then I'm going to use my space bar. In fact, I'm going to delete my common. Right, I'm deleting things that you can't see. Alright, now I'm going to show my sketches. So I start off by making this in much the same way. From the part workbench, make a sweep. And I sweep this profile along this path, just as we've done before, and generate this surface. Next, what I think I do that's pretty interesting is I take my surface and I go to my part workbench and I extrude it. We're going to say, how about 200 symmetric, and then I know it just goes through everything. We're going to say OK. And I simply take my sweep and my extrude, and when I run a common, it trims my surface, right, to the sketch that I profiled. So there's a surfacing tool where we can trim surfaces just using solids. So now this is my goal to talk a little bit more about this surface workbench. So we go to the surface workbench and it gives us some extra tools that are specifically dedicated to surfacing. It's one of my favorites because of how simple it is. So this allows us to create a surface from a series of edges. So I can choose something like add edge. And if you can tell, I can go all the way around my mouse. And when I choose a close barrier, you can see that this shows up. So I can make a surface that makes for the bottom of the mouse, right? And that's where I got a little bit in trouble because I went a little bit eccentric out here. Nonetheless, when we just wish to make a surface from a bunch of boundaries, we can use this tool. Likewise, we can create a surface from 2, 3, or 4 boundary edges. So from here I can choose this edge. Oh, of course I have to click Add Edge first. This edge, and this edge, and this edge. You can see that we can start stitching, if you will, this closed. So we can use this tool to run between a bunch of edges. Go here, and there, and we just start stitching these kinds of edges closed. I'd like to go over another tool in the Surface Workbench, and it's easier just to get away from the mouse for a moment. I've got 3 arcs that I've sketched out, and we can create a surface between these, much like a loft with this creates a surface from a series of sectional edges. So if I add an edge here, and here, and here, you can see that we create what we would think of as a lofted surface, which is pretty simple and straightforward. Now, FreeCAD documentation goes into pretty good length on talking about twisted surfaces. Sometimes you may end up with an unintentionally twisted surface when doing this operation. And if that's the case, it says to reverse the points with which you make the geometry. So if curve 1 has points A, B, C, and D, then generate your element with D, C, B, and A. And that will undo the twisting of the surfaces. So as I've said before, surfaces are not the end product. They're just a means to the end to generate whatever you want to make. You don't sit down and say, oh, my finished product is a surface, because they don't exist in reality. So what do we do to work with our finished product surfaces? Well, there's a few choices. As I've shown before, you can use a surface to edit a solid, right? We split that shape to make the top of a mouse and make kind of a mouse shape. But there's some other things that we can do too, right? I have my existing surface, and we can go to Part. And there's some surface editing tools here on the Part workbench as well. If I select my surface, I have this little offset option, tools to offset shapes or construct parallel shapes. So I can run a 3D offset, and let's say I want to fill my offset, and let's offset this something like 3 millimeters, and you can start to see our surface is now getting to be a solid. I say OK, and we actually are working with a solid now. So offset and fill offset is very, very awesome to do. I show some tools on using not a filled offset, right? So if I edit my offset and I don't fill my offset, it gives me 2 parallel surfaces that are offset from each other, but they're still surfaces. So offset is a tool that you can use both to generate solids and to generate parallel surfaces. If you wish to use 2 parallel surfaces for something, I think I do that in my other mouse video at one point. So catch both my mice videos if that's important to you. Likewise, we can make surfaces watertight and convert them to solids. And what do I mean by that? Well, let's go back to our surface menu here, and let's go with create a surface from these boundary edges, right? So I say add edge there and there, and we create a surface between these points. Let's create another surface here, here. Oh, I have to add edge first. Here, here, and there. And as you can tell, I'm starting to create a closed shape of surfaces. Let's do that again. here, and of course I have to say add edge here, here, and there, right? So this is our last one, and when I close this face off, we have a watertight group of surfaces that have this hollow center to them, and that's what we want, right? We want a shape of surfaces, in this case, that's hollow tight, or watertight rather. Add edge here, here, there, and there. And we say OK. So there's a tool now, and this will be found on the Curves workbench. And it's right here, this green guy, make parametric solid from selected faces. So I just hold Control and select all of these faces. And once I have every face selected, boom, now I have a solid that I can work with. And if I want to test this out, just to make sure, I can do a quick little test here. I can start sketching on my plane, right? We'll draw a little circle, which we don't see. There's my circle. We'll go back to the part workbench, close our sketch. We'll do a little extrude, make sure that it is symmetric. And let's say along 50, and OK. And then I can select my solid and my extrude. I can do a little cut. And as you can see, we have hard edges here. So we know that that's solid. So a few strategies, right? With surfaces. You can make your surface and offset it and fill it. You can make a surface to edit a solid with, or you can make a surface and make it watertight like we have here, and then convert it into a solid. And those are ways that we can use surfaces to augment our abilities in modeling that it would be difficult to do otherwise. In the part workbench, right, there's a few other things that are very useful. We've got this create paramitized geometric primitives, and this allows us to make something like, how about a helix, right? We can choose our pitch, let's say 10 millimeters. We can choose our height as something like 100 millimeters. Our radius, let's go 50 millimeters. And our angle, how about 45? We'll create that, right? So we can make these really cool helixes. And I accidentally created two, so I'm going to delete one. And if I create a sketch now, of course I have to do it on the sketcher. And we would care about the ZX plane. Then I can even import, I can import that and it will lay flat, but I can import just that little end there. And I can choose something cool, like maybe a hexagon would be interesting. And we'll say H for horizontal. From here to here. Say Shift V to give this a height of 5 millimeters. We'll close that. And I can interact with this stuff, right? I can go back to my part workbench and I can choose something like a sweep, and my profile will be my sketch, and my sweep path I'll hold Control and just select all the elements. And then I say done and OK, and I've just swept a helical, conical surface that is a hexagon all the way through there. And of course, I need only select solid to be true to make this work out as a solid. Now, in part sweeps, you may also see this option of Frenet, and Frenet is pretty cool. You'll see I just changed to true, and there's not much different. So if you have a sweep that doesn't go as predicted, change Frenet to true, and it changes the way that the profile follows the path, where it tries to stay normal to the path at all times. And that should fix any unexpected behaviors and sweeps with Frenet when you use that. So excellent. You have these cool things. So we just did a helix, and that we kind of turned into a cone. But we also have these sort of primitive shapes where we can make ellipsoids, toruses, circles, spirals. Spirals pretty cool. And polygons and whatnot. So check this out if you ever need to do any of these cool primitive shapes. Why don't I save this? All right, from the part workbench, let's discuss a few other things that are pretty fun. I had to show you that surface workbench for what I'm going to show you now. So let's make a sketch, by which we'll make an extrusion. I like the YZ plane for this, I think. So in this sketch, I want to create a spline because a spline makes for a nice complicated surface. So this complicated curvy surface, and then I'm going to close it off. Again, in serious sketches, fully constrain these. I am showing this for the sake of time, hoping that the first video gave all the skills needed for full constraints. So with the sketch highlighted, we'll run back to part, do an extrude, about 50, and OK. You know what, I'll edit that. I'll just stand on extrude and change my distance here to go from 50 to 200. All right, great. So if you have like a car tire or something and you need to get text or something on this surface of the side of this tire, because you know, you look at the side of a car tire and you have all this text and symbols and stuff. How do we do that in FreeCAD? Well, let's create a new sketch from the sketcher. And this time the ZX plane will be about right. So XZ, we'll offset this, say 50, well, 100. We'll say OK. You can see, you know what? We're sketching on the wrong side. So let's take this sketch. And here on the position of this sketch, we're going to say Y is negative 100. And that's how we undo what we've just done. And now we're sketching on the right side, right? We want to be on the curvy side. So we're going to go to the front. And for simplicity, we'll just add this guy here. And we'll close. Next. Let's go to surfaces, and we'll use our boundary surface. And we'll add our edges here. There, 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 and there. So we've just created a surface from those boundaries. Next, we'll head on back to part. We'll choose this project. Our projection surface, of course, will be our complicated face. And now we're going to choose our front plane where we look straight on, right? We're going to say get current camera direction, and that will be our projection direction. So you want to look straight on in the distance that you want to project. Since I want to project on my complicated face, of course, I'm looking straight onto it. And then I'm going to say add face. I'm going to choose this guy. And you can see we're projecting off of this face. SolidWorks has a similar feature, and it's called wrap. So we add this, and I'll use my spacebar and hide these things. And so this is created as a separate body, right? We have a body here, and we have a body here. And so, as always, to finish off, because part makes everything in separate bodies, I can choose project object from my tree, and I can choose extrude object from the tree, and I'll choose make a union. And now I can select the edge between them so I know that they're actually a single solid. So that's a very useful way in being able to project off of crazy NURBS-like surfaces. If I haven't mentioned already, the very, very overly simplified definition of a NURB surface is a surface that cannot be flattened. So this one can be flattened, so it's not technically a NURBS surface, but any surface like that top of the mouse surface, that one can't be flattened without distorting it. So it would be considered a NURB surface. That's a very simple, maybe overly simple definition of NURBS. It stands for non-uniform rational B-spline. Has a lot of history. I think NURB surfaces started in 70s CAD modeling and originated with IGES files, which, I don't know, all that stuff in the history behind CAD is kind of interesting to me. So, all right, we have this sort of projection ability. Let's maybe do a save as here. All right. Let's start a new part. So we've walked through much of the part workbench. Let's talk about some of the other add-ins and how they might interact with the part workbench. So first off, if I pull this menu down, I think I probably have more options here than you do if you're running a factory FreeCAD just install. So what do we do to get more things? Because I love the curved shapes workbench. It is absolutely phenomenal. And you probably don't have it. So when we want to add things into FreeCAD, we want to go to Tools, Add-on Manager, and it says, of course, be careful and know what you're installing. And we have all these options of workbenches that we can install in FreeCAD. I don't think there's a limit to what you can install, so you can install every single one of these if you like. How about the Mars workbench? I don't think I have that one. Yep, so the creator of the Mars workbench actually commented on one of my Mars workbench videos. I have a whole video on this. It helps you make guitars, actually. You can make guitars really easily with this workbench, and it is so eloquently made. It's just, this one is just so amazing. So if I like the Mars workbench, I click Install. And now that it's been successfully installed, we have to restart FreeCAD in order to see it. So when I close, it asks me if I wish to restart FreeCAD for this workbench to show up. I'm going to wait, but the next time I close and open FreeCAD, I'll have the Mars workbench in here. So go ahead and install the Curve Shapes workbench. And the interesting thing about curved shapes is, well, first we need to make sketches. I can, if I wish, use the part design to make sketches on, if I like that interface, which I do. And the curved shapes workbench was made for airplane wings, right? So I'm going to make just a simple something that looks kind of like an airplane wing. Oh, how about I'll choose a rim point arc instead. So I'm just sketching out. I'll do T for tangent and make sure that these are tangent. Shift, cancel. I think I selected the wrong thing, so we'll go Shift H there and say negative 200, all right, whatever. We'll say Shift R and we'll say, 10, right? I'm trying to just make a simple plain wing looking thing. Shift R, 1000, right? So that's 1 meter radius. So we'll close that. Next, it's probably not required, but in my mind, I think it's best practice to edit the sketch. Let's make this for construction and replace it. We'll go center and endpoint. We'll select our center point right here. And we'll go with 2 arcs right there, and we'll say get those points together, and we'll make it horizontal. And what I've done is I've put a point on the rightmost point of our foil in my view, and I have a point in the leftmost part of my foil. I want both of that, right? I want to mark my leftmost and rightmost point of my foil, or in other words, the very front and the very rear. I also have a point here that marks the very bottom, and a point that marks the very top. So when I go to the rightmost point, there's something that marks there, right? A little point right there. Leftmost, I've got a point. At the very top, I've got a point. At the very bottom, I've got a point. So that's important to have, in my opinion. It'll probably work without it. In fact, I think I know it'll work without it. But in my opinion, that's the best practice to constrain your very first sketch that way when working with the Curve Shapes workbench. So we've got a plane wing, which is what the Curve Shapes does best, but you can do a ton of things with the Curve Shapes workbench. Next, let's go to my top plane. Let's make a little footprint for my wing. So I'm going to say OK and start sketching on my XY plane. And I'm going to import rather, my rightmost and leftmost points. And how about I grab a spline? And I'm just going to make what I hope is a simple looking wing. That's kind of cool if it bends backwards like that. So I've got my simple wing. Yes, we're constrained to all of our points. And I don't know if this point's going to show up or not. I'll tell you what, I'll just pull this out, and I think we can think of that as our topmost point, right? So I've got this little footprint of a wing going on. Perfect. Next, let's grab another sketch. And I can import my top and bottom points. That came in as a line, I think, but that's okay. Again, why not use a spline? Good. Now let's modify our spline just a little bit. Maybe, yeah, that's kind of a groovy shaped wing, right? We can make this shaped however we wish. I'm going to go ahead and also import my, you know what, I can import the whole spline, can't I? Apparently it failed to add the external element, but that's okay. Our last sketch, we've got a little wiggle room. So I'll just make this a little bit extra wide. So let's close that. So as you can see, we've made a wing that we've sketched what it looks like from the top. We've sketched what it looks like from the front, which I guess are kind of overly thick there. But we sketched what it looks like from the side, right? So when we go to Curve Shapes, I've got this option to create an array and resize those items in the bounds of the curves. And then we have create an array and sweep the elements. I care about this one. Create an array and resize the elements. And of course, I didn't select anything, so it came in broken. Let me delete that. And first, I'll select, and this is very important, my first sketch must be my foil shape. I hold Control. My next sketch is this shape, and my next sketch is this shape. Those two don't really matter in order, but this first shape is very important. I select this first one, and I get this sort of, I don't know, foil projected looking thing, right? It just created a few of these black things. So I go to my curved array, and let's say true for solid. All right, it creates a wing that kind of looks like what I've made. In fact, this is actually the best thing that I've seen so far. But as you can tell, there's some imperfections that doesn't match our profile perfectly. So we can increase our precision by going from 4 items. Let me type in 50 items. And if I go to my curved array and say solid is going to be false, you can get a better idea of how it is modeling our wing automatically. It's creating all these profiles that just sit within our sketches, like so. This little last guy might be throwing us off a little bit. Let's see how it works. Solid is true. Yeah, so we get a little bit of awkwardness at the end, and that's okay. We have this idea of saying offset end, and if I say 0.1, you can start to look at fixing 0.2, right? You can see how we're changing our end profile with the offset, 0.35, and it starts fixing that end so that's a little bit less abrupt in transition. So you can offset your start and your end if you get some unexpected behavior. And we can always turn our solid off and turn our surface on if we'd rather work with the wing as a surface. It's just a totally brilliant way of doing things. Finally, this isn't just for wings, but it works really well for wings. Anytime you need to make a curvy organic shape, you can use this workbench. So I can work on twisting this profile even though it wasn't meant to be if it's a wing, right? I can say 1, 0, and we get a little twist in there. This isn't revolutions, by the way, it's something else. So as you can start to see, as I increase the number, I increase my twisting profile, which makes for something actually truly amazing. So if I say 500, right, and I twist the profile all the way down. So it's a pretty amazing thing to be able to do all this. Now, if I say back to 0 for a moment, and I take my sketch, right, I can always go with something more extreme if I wish. And you'll notice we're a little bit slow to select and move things, right? When you have this kind of lag, it's because we're trying to rebuild the wing at the same time as we're adjusting the sketch. So one little trick, if you get a lot of lag, we'll go to whatever part we're working on and we'll say skip recomputes, and that will stop it from trying to recompute our body as we adjust the sketch. So I go back into my sketch, right? Notice I can adjust things a little easier. Right, what if I wanted to make my wing kind of more of an extreme shape? I don't think that'll fly well, but it looks cool. We'll close that. And notice we skipped recompute, so nothing changed, right? We have to hit this little recompute to recompute manually, and then our wing updated to the sketch that we just made. So we can always make this whatever profile that we wish, and it's so powerful and so elegant that we can go with something like, you know, all this twisting. I should back it off, right, and do, I don't know, some kind of fun twist like that. So that is curve shapes, and that is just one tool out of curve shapes. We have a lot of other abilities. I have a video on this that I go through more tools, and there's also documentation on GitHub that covers all the things you can do with curve shapes. It is such a simple but powerful workbench. Again, so eloquently made. So go check that out. I'll save that, and I'll save that with 0 so that it looks a little bit more like a wing, and we'll do a save as. So the question is, once I've made my curve shapes wing, and I make another body that's like the body of a plane, how would I merge this wing with the body of my plane? And the answer is part union, right? And that's why I went through the part design workbench so much. If we have like a cylinder body to our plane, which I've just created, I don't even see it. Let's go with radius 100. Okay, there it is. Radius of 50, and then we can transform this. There, right? So if we have a cylinder plane body, which is quite small for this wing, but that's okay, and we give this a height of, say, 500, we'll make that in the negative direction. I guess I just have to translate it here. And then we go to part and we select our curved array and we can make a union. And of course, when things disappear, this is also a good moment. When things disappear, it means that there is an error in being able to merge them together or fuse them. So we'll just delete that. But that is, in theory, how you would do it if there was no error. That's kind of awkward that I run into an error here. Radius. If I increase the radius, does that make a difference? Yeah. There's some kind of big problem. So hopefully that doesn't happen to you, because that's not happened to me when I was building the Corsair. I didn't have a problem with that at all. But anyway, so you can use sketches from Part Design, or you can use sketches from the Sketcher. Curved Array doesn't care. And then you can just fuse them together with something that apparently isn't a cylinder or something that has an error in it. It very well could be this edge right here that's throwing everything off. And if you wish to check that, there's a great little checker in Part Design, right? I can stand on my curved array and look at this. Analyzes geometry for errors. Make sure that this BOP check is not run for your first run through. We're going to say run check. And we have no invalid shapes. So we'll go back and again stand on our curved array, run check, and now we're going to do a BOP check. Wow, interesting. Very, very interesting. BOP checks are, if you have a failed Boolean, a BOP check can sometimes tell you what was contributing to that failed Boolean. However, BOP checks can give you false positives. So make sure that you know what you're doing when you run a BOP check, and you don't think that everything that comes up with a BOP check is actually wrong, right? You can easily get false positives. But I'm in the mood to experiment and troubleshoot this, so let's try to offset our end. I'm going to go something big. How about 10? Right, so we've created this big offset at the end of the wing. And with that offset, does that correct some of the tricky geometry as it goes to merge? Let's find out, right? We've got our cylinder and our curved array. We'll merge these together and we still come out with an error. So I'm not sure exactly what's wrong, and I'd have to play with it a lot more to figure it out. In the meantime, we've got a lot more useful stuff we can go through. So that's how you use the part workbench to integrate things. Sorry that there was an error and I didn't actually visually get to work on that with you. Okay, next, how about we close this too. So from part, let's go to Part Design. And we'll make something in Part Design real quick. We'll start with the XY plane. We'll make a rectangle, and we'll select a corner, opposite corner, and the origin. And we'll hit S for symmetric, and that maintains the box being symmetric about the origin. We'll say Shift V for vertical dimension. We'll call that 75 millimeters. Shift H for a horizontal direction. We'll call that about 150. We'll close. pad, also known as extrude. We'll say 15 millimeters. We'll select this face and utility to apply thickness. We'll make sure that this thickness is set inwards, and I'll make this 3 millimeters thick. And then I can select about my 4 inner corners, and I'll hold Control, selecting each one. I'm going to choose fillet. We'll give fillets of something like 11 millimeters, right? So we got something that looks like a business card holder or something. And let's say we want to machine that with a CNC machine, and we wish to generate the CNC code to tell the CNC machine how to make this part. Well, let's talk about how the Path Workbench can do that, and we'll take a real modest look at the Path Workbench. The first thing when I go Path is I want to add this container. It creates a path object. So I click that once, I click OK, and it asks me in this menu about my stock. You can see I've got this invisible box surrounding my part. That invisible box is representative of the dimensions of the stock that you'll be using to machine down into your part. So I can say take my Z dimension and make it 100 millimeters, and you can see how when I change dimensions, it changes the dimensions of my stock. Well, I don't need it to be 100 millimeters, so I'm going to take it down back to 1. I always have used the default settings on this because I actually don't CNC machine stuff. I did have some CNC training in school though. Let's open up our job here, and let's come down here to Tools, and we have our default tool and our end mill. Of course, we can double click on our end mill and either edit the dimensions and settings of our end mill, and we can go to Attributes and see, flutes and stuff. So I can make it 2 is kind of small. 4 flute, that's a nice mill, right? We can also change out our tool with some other kind of tool that is pre-installed into FreeCAD, and all of those can be edited as well. So those are the options on how you can change and edit your tools. We can go to our operations. Currently we have no operations. So let's add a facing operation, right? Maybe we'll want to face off this face. I believe this one is facing. Yes, create a facing operation on the model or face. And if we look at our mill face here, so I just say apply and OK, and there we have the tool paths generated to do our facing. If we have any questions about that or what it's going to look like, we can come up here and say simulate G-code path on stock. So we're going to play that, and you can see exactly what our G-code path looks like. Now we may not be satisfied with these things being left in here, so maybe we can change our path a little bit. So we go to operations, and there's our new mill face. And we can change, of course, our zigzag pattern to maybe something like offset. And then I'll hit this refresh button to update that. And let's just take a look at what that looks like if I simulate the G-code real quick. Yeah, looks a little bit better. But we still have a little shelf up there. So let's take a look at what else we can do. Clear edges is true. And that does our edges, right? So we've faced the top, but now we want to do the sides, I would imagine. So I'll stand on my body and we'll say profile the entire model. And yeah, that's all looking good to me. Of course, we can change these settings if we wish, but I'm going to apply it. And now we'll simulate the G-code. And then we go around and we face the entire model. All right, now we can do something like, if I select my bottom face down here, we'll say we'll create a path pocket. I, again, can look at the operation, think we're okay there. So let's okay that. Go to our pocket shape. I can drag this out if I want to do a little more reading. I'm going to change zigzag over to offset, and let's simulate our code. Right, so we do our facing operation, and we come around, do the outside, and now we're offsetting the inside, and we have some material left over from our default settings. I don't think we want our finished product to have that, so let's go to our pocket shape. And we have a lot of options. Let's take our step over. Let's take it down to 50. We'll rebuild that and simulate the G code. Go around the outside. And by using a different step over value, we've successfully stopped having too much material around here, right? So this is just a simple example on how we would machine a part. A few other things, you can do a 3D path pocket object from a face or faces. I think adaptive clearing, right? That's very popular with CNC right now. I think it extends your tool life and is uber efficient. And you can also change like the route that your entry points take, so you can enter in with more efficiency. This is just a quick overview to show the capabilities of FreeCAD and really the thing, how powerful it is. But if you want to look at the details and a lot of the minute features that the Path Workbench has to offer, I really recommend a channel called Sliptonic. I don't think there is any authority in the world better at Path than Sliptonic. They're a great channel. Check them out to learn more. So this is a quick overview on the Path Workbench. Hope it was helpful, and let's move on. Moving on to something else. We're back in part design. I'll create a sketch on the XY plane. Much more simple this time. How about I make a rectangle? I do the same thing as before. Grab opposite corners, the origin, and S to make it symmetric. Shift V, how about we make this 100 millimeters, and I'll choose these and make them equal with the E key, and we'll close. Next, let's go to sheet metal. Sheet metal is a really fun one. So I can make a base flange, or a wall as you'd call it, simply by having my sketch and clicking on this wall, and it makes me a little sheet metal part here. I can highlight base bend in my tree, and I can start editing my parameters, like my default radius. Maybe I want that to be 2 millimeters. And we can adjust the all-important thickness if we wish. And you think, okay, well, I could have just extruded that or padded that, right? And had this piece of sheet metal. What's the advantage of the sheet metal workbench? And if I select an edge, and now I can add in a bend, right? And I can start making a sheet metal object in the folded or bended form, right? And I can just stick a negative in front of things that I wish to reverse. And I can make whatever radius I want, right? I can go with a radius of 3, and this bend will get larger. And then I can select, oh, also I should also mention, you can invert it, if you don't want to stick a negative in front of it. And you can change the length, right? So I can go 20 instead of 10 if I want to, and then I can add in another piece of sheet metal thing, and I can invert or stick a negative in front of that. all sorts of options. And what is even more important is we can adjust the K factor on this stuff too. So we can actually compensate for stretch that occurs when we bend it and have our blank have that stretch pre-built into it, so it'll be the correct dimensioning after we bend all these things. So we can change our relief types if we want to. I don't think I have reliefs on here. Yeah, well, let's get to the other point here and say, how do we flatten this? There we go. So I'm going to highlight one face, and I choose this button right here, Flatten Folded Sheet Metal Object. I have to make sure that I specify either ANSI or DIN, and make sure that I have a K factor per whatever material I'm doing. 0.5 is fine for me. And when I say OK, it generates what this should look like in the flat, and it generates bend lines. So it's very, very helpful if we want to manufacture anything for sheet metal. I also can just delete this stuff if it's kind of visually in my way. There's a few other tools that are really cool, right? But mostly when I do sheet metal, I just add bends. So we can extend a face on the sheet metal if we wish, and then add another bend, right? So that's just a nice little extend tool. Again, I can make this guy come out a little further with the extend, and then I can go into my extend, of course, and specify an actual length value like 30 if I want it to be longer than what the default is. And we can make some really crazy sheet metal shapes, and they all work really well. So I haven't really done rip. It's a really cool feature. I just have never had a need to do rip. Yeah, a lot of these tools are a little bit newer than the version that I learned on, so I have some learning to do myself on here. But that is the basic sheet metal workbench, and of course you just highlight whatever face you want to be stationary, and then you can use your flatten, and it will flatten things for you. Another thing that can be done, if we go into part design, let's go with our XZ plane, and I choose my polyline tool. If I've got a really complex flange that I would like to make, right, I'm just making, as you can tell, some random shape. And as always, best practice to fully define everything that you're serious about. All I have to do is go to sheet metal rather, click on my base flange, and it makes that profile in sheet metal for me. And it is something that you can still flatten, right? So I think that that's really impressive for FreeCAD to be able to handle something like that. As always, you can take your default radii. We can make them something like 3 millimeters, and you can see it updates all of our radii. And we can take our thickness, and you can even reduce the thickness to something really thin like 0.2, and it just updates. So it's a great workbench. Highly recommend it. Yeah, let's move on to the next thing. So let's head to part design and create a new part. And I'll go on the XZ plane. We're going to make a basic, how about a U kind of shape? And in this case, we'll do a sideways U. Yeah, we'll put the origin there. And then we'll take this point and put them together. So we'll take these and say E for equal. These lines, E for equal. This line, H for horizontal. We'll get some dimensions here. Shift H, we'll make that. How about 30? Shift V, we'll take this vertical and make it something like 20. This guy, Shift V, we'll do something like 100. And then I think this is the last thing. Shift H, we'll do 15, looks good. All right. So we've got this sort of sideways U shape. We'll close it. We'll do a pad. We'll go 50. And now let's go to the FEM Workbench. And it looks like my toolbars are different than I like, so let's readjust those. So let's put a load on this part and do a stress analysis to see, what parts get stressed with what load that we do. This is a mile deep and a mile wide, so we're definitely going to be kind of modest, but we're going to start off by putting our analysis container in the tree. And that holds our solver. Next, I'll give this a material with this yellow circle. And Calculix steel is a pretty good material for what we're doing here. But I'll just choose steel 1C22. Okay, and then we'll go with, you can do a lot of options, right? You can do a thermal analysis, a thermomechanical analysis with both temperature and stress. You can do other things. We're going to do a basic analysis here of just stress. So we're going to take this face and we're going to put a fixed FEM constraint on there. So we select a face, we say add, and OK. Then we select this top face. We can choose pressure or force. I'm going to do with a force, let's say 10,000 newtons. We'll select this face and say add. And then we can reverse the direction of our force to make it more compressive. Right, and then we'll need to do a mesh. So I'm going to stand on my body right here. And I'll choose G mesh. It's a very simple mesh, and we'll see if it works. Our max element size, let's say 20 millimeters, and we're going to say apply. Yeah, I've got an error executing G mesh, and this might be the way that I've installed FreeCAD. So I'm just going to get rid of my G mesh, but that is basically what you do for G mesh. If you're like me, which you probably aren't, but you can also use N mesh right here, and this one tends to work. If I say very fine, and I go to apply this, you can see that we've made a pretty good mesh already. But let's turn our max element size down to 20 and apply that. You can see our mesh gets finer and finer. What this mesh is like, it's like a truss system almost, where the points where the mesh meet are nodes, and we calculate the stress at every node and how we can use the mesh to propagate a force through a complex object, simplifying it with a mesh. And that's kind of a basis on how we do this analysis. So let's say 5 for max element size, right? The smaller the mesh, the exponentially more calculation you have to do in the analysis, but the more accurate your results are. So there's a point of diminishing returns where you're doing huge amounts of calculation for not much difference. So a lot of the nuance of analysis is the mesh. What kind of mesh? What size of mesh? And how much calculation are you looking at for what results? And you have to make these kind of hard decisions if you're going to do analysis as an engineer. So we've got this done. I'm going to double click on my solver. We'll write an INP solver file and run Calculix. And now we're solving this with the force and the fixed face, and we're done without error. So let's double click on our results. And we can visualize our results with our, say, if I highlight displacement magnitude, right? The green stuff doesn't move very much and the red stuff moves the most. And this makes sense, right? The places where we have the fixed face sees little to no displacement. The places that we see the most stress move the most, or the places furthest away from the fixed face. We can tell already that our absolute max magnitude is 1/10 of a millimeter. And we can show, if I click show in here and I drag my slider, you can see the way that we're moving. Now, as we show this force, I want to say this is a lot more than 1/10 of a millimeter that we're moving, right? So our slider max is set to 100, which means that it's 100 times more motion than you actually see. And that's very important. If I set this to, like a 1-to-1 ratio, you can hardly tell that anything is moving under load there. And when you do an analysis, one of the first things that is good to look for is, one, balance your forces. Make sure that the reactive force equals the input force, so that you know that everything's accounted for. But you also look to make sure that this movement is realistic. Is this moving in a way that I would expect? And if it's not, that's a great way to catch errors in your analysis. So we have this, and this is looking really good. I can make this 10,000 if I want to go really crazy. It's kind of fun to watch. It's almost like a cartoon-like force. But not only just displacement magnitude, but we can look at von Mises stress, which is also very helpful to see what parts of my model are the most stressed. Look at that. And that also seems to make sense with the forces and everything that we're dealing with. And then we can look at, what is the displacement, but only in the x direction. Right, and the movement kind of reflects x direction movement. Right, we can look at shear stress. And of course, we get the most shear stress around where we get the most von Mises stress in this case. All right. There are other ways to visualize the results. If I stand on my CCX results for a moment, and I go to this like green windows looking thing, this is a pipeline for post-processing, and it adds this little pipeline part of my tree. So if I double click on that, and I say, oh, maybe I want to envision my nodes, and I want to see how they displace, right? I can look at every node and get a better idea just by looking at the nodes with more of a rainbow color scale than we had before. We have some pretty yellows and stuff. And we can visualize the surface or the surface with edges. This is a particularly helpful one. If anything, when you look at something, the colors are really pretty, but don't get wrapped up in the colors, because when we'll do displacement. When we look at something like principal stress, we're only calculating really at the nodes, and the pretty colors approximate averages between the nodes. So if we just look at the nodes only, right, these are our calculations, and it's better to keep in mind that these points are what generate the pretty colors. And so these are the only known points, and everything else is an average in between them. These kinds of tools can be helpful to remember what we're actually looking at with an analysis. So that's a quick example of an analysis. I've got a lot more analysis types and techniques on the channel if you'd like to learn more, but that's a basic stress analysis on a part like this. I'll save that as an analysis example. Two other workbenches that are worth mentioning here. If I move into the FreeCAD gear workbench right here, and I start a new part, you have all kinds of things. You have a spur gear, and you can make a gear rack. I'll try to line these up. This is a cycloid gear. Looks a lot like a spur gear, but it has a different tooth profile, I believe. You can have a crown gear. That's a bevel gear, pardon. You can have a crown gear. You can have a worm gear. And for each of these, well, I guess I'll show the rest, right? You can have this, I think it's more of a timing belt gear. It is, there it is in the tree, timing gear. Lantern gear. I'm not that familiar with lantern gears, but they sure look cool. And what is this? Hypocycloid gear. Another thing I'm not that familiar with, but on each of these, and I almost always use involute spur gears like over here. Right, the involute gear has the module, the height, the number of teeth. There it is, teeth. So I can give this 100 teeth. And it's really nice to be able to put a lot of teeth on an involute gear. Some equations really kind of fail when you try to do that, but this is looking really good. So you can start customizing these gears really well. Clearance, head, right, we can make the height like 1 millimeter if we want a super thin gear for some reason, and it just works. So when you have the module, which is the metric way of saying diametral pitch in a way, the module is the inverse of diametral pitch, where one is teeth per length, the other is length per teeth. But when you match those up with other gears, you can start to know that gears are going to mesh properly. So this is a very useful workbench for having all kinds of gears. So this is very worth looking at because you can customize each of these gears to your specifications, and they're actually an involute profile where they work and mesh properly and are ready to use. They're not just stand-ins for something that does have the correct geometry. They actually have the correct geometry. So we'll close that without saving. Create a new file here, and let's go with fasteners. So what we've just done with the gear workbench, we have the fasteners workbench as well. Right, we can just generate a fastener, and you can see all the different kinds of fasteners that we can generate up here. And when we go to customize these fasteners, one of the really great things, people love this for 3D printing, we'll take this kind of screw and we'll actually turn the thread to true, and it gives us a very realistic screw thread. Now that's very computationally expensive to have helical features like this, so only do screw threads if you need it or your models will slow down. You can tell how much longer it is to generate this one than this last one even. There we go. So screw threads are computationally expensive, but you can add them if you absolutely need it. Right, and then you can, if you need a female thread, you can go to the part workbench and put this in your part and then subtract it, and the subtraction will leave a female thread, so they're really, really handy. And of course you can generate all kinds of washers and screws and just handy things. So that is your screw and fastener workbench, which I find very interesting, and I love looking at such realistic threads in CAD. It's really fun to look at, right? A little set screw there. So fasteners are the exact same concept as gears. You can generate almost anything and customize it with its attributes to become anything you want, at least within reason. So that's gears and screws. Finally, let's do something else. Let's go to part design. Create a sketch on the XY plane. Maybe I'll make a slot. We'll say Shift R, 25, Shift H. We'll go from center to center here, 100. Close that, pad, and 150. How about? All right, make kind of a groovy part, and then we'll do another thickness similar to last time. We'll go 5. Okay. So what if we want to make drawings of parts? I think this has the features that would be important to me for this level. Let's go to Techdraw, where we can make 2D engineering drawings for our parts. We come in here to insert a default page, and we can adjust our templates if we wish. So in our tree here we have page, we have template, and then we open this up and we can adjust our template here, right? We click here and here's a bunch of sizes and templates that we can use. How about E3 landscape? Right, that's a big sheet. So if I stand on my body here and I just go to my top view, I think it is generally important to have your camera set on a top view for this. We can come over here and insert multiple views. And so we can go with our top and side, for instance, and we go to our page, right, and I can just insert these views the way that I want to. Likewise, I can do an isometric view if I find that to be something that's helpful. I don't recommend dimensioning isometric views. It's not a normal practice for the kind of workflows and standards that the Techdraw Workbench was meant for. And you may be able to dimension it, but there's no guarantee it'll be right. And it's not really an industry thing to dimension isometric views for serious drawings. If you do dimension these, make sure that it's right. And I think there's a script or a macro out there that can help correct these. So be very careful if you dimension your isometric views. So from here, what if we want to define this, right? I can grab this line. And by the way, you know, these are kind of thick lines. This view and everything could be kind of generic looking. So we can always edit this stuff, right? We have view and data, and between view and data, we're pretty well set with everything that we can edit. With our line width, we can say 0.2. That looks, you know, very, very nice. I think in comparison, I would like 0.2 to be a default in FreeCAD, but I'm not a developer and I don't call those shots, of course. So that's just my opinion, which is probably not worth very much. So here's all of our lines adjusted to our views here. We'll go to vertical, right? We've got 15 millimeters high. Notice I've set it to be from this dimension instead of this one. So I can always select, say, 2 points. I can select a point here and a point up here and add in a vertical. And I have 150 and 155, so you can deduce the radius there. Or I can just make it extra simple. Select my circular edge there, add in a radius, and I can say that I've got my radius of 5. Very simple. All right, so there's my top view. I can add in a radius here. I also can choose a diameter button, right, and it will add a diameter even though that specific dimension would not be measured by diameter. What if I want my circle points? Well, I can do that. If I select my view, and it takes me always a second to remember where everything is, but I can say my arc center marks are true. I get little arc center marks right there, right? So I can dimension off my center marks. I can choose this center mark and this center mark, horizontal, and I can dimension the center between those. And maybe if I add a redundant dimension, right, like this out to out, well, it's a bit redundant to have a radius of 30, and it would actually double up the tolerances in very, not very nice ways. So we can adjust that. So because of this redundancy, right, I can choose this theoretical exact and say true. And that makes it a basic dimension. I also have all these options, especially in view, to say do things like flip my arrowheads if I'd rather have them on the outside. And I can change my font with all of these. Padma. But I really do like Ozafont. Where is that? Right here. I can change my line widths on all my leaders. And I can change my rendering extent if I wish. Oh yeah, minimal. Ugh. I'd have a hard time reading that. So I do like normal for that. You can also change this kind of display for ISO and ASME standards. I tend to use ASME in my personal work, but either way, they look good. So there's a lot we can do with customizing these kinds of dimensions as well. I do have some more information on this in my other videos, but needless to say, we can add bubbles if we wish. Right, so if I have an assembly, I can just bubble this stuff out and it works really well. You can export this to a DXF format if you need. You can add text and annotations. Leaders, there's some weld symbols in here. So there's a lot that you can do. Again, more information is available in some of my other videos. So that is how you can make drawings. You can also custom make a drawing template from an SVG file. So you can do 2D drawings, and tolerances are important. I should probably walk through that, right? Come over here into the data tab. We're going to say like 10, and then we can have plus or minus 10 or 1 or whatever tolerance that you want. So that's how we do the basics. Let's move on to another one. I'll save this as drawing example. So if I create a new part now and I go to A2+, A2+ is where we make an assembly or put multiple parts together. And to add a part, right, I guess it's best form to save it first. So I'm going to say assembly example. And then I'll take add a part. And I'll insert what I have as a base right here, and you can download this from GrabCAD if you'd like to follow along. If I don't have a link to this, remind me. Lots to do when you upload videos. And I have this base. So when you insert a file into an assembly, you of course want at least one file to be fixed, and that's usually the first part that you put in. So I have fixed position as true, and that's exactly what I want, right? If I make it false, I may not be able to click and drag it with my mouse, but you will notice problems later on. So make sure that your first part has a true fixed position. Next, I'll insert another part, and I want a relationship between the parts in my assembly, right? And you'll see that if I highlight a part here, my fixed position is false for this part, and that's what I want for my subsequent parts, because I want to define them in relationship to my fixed part. So as of right now, I have a little degree of freedom checker. So both of these are coming up as free. Let's see if that's true. So we'll test that as time goes on, but let's try to establish a relationship between these parts. Right, let's say I want this face and this face to be right up against each other, or what we would call coplanar. Right, if I click this coplanar button, then you can see that they're coplanar but in the wrong way, right? So I want to flip my direction here. And now they're touching faces just like I want, so I accept that. Let's say I want this circular face and this face to share the same axis. So I'll use the axis to axis constraint, and that's exactly what I want, right? Now, if I look at my degrees of freedom, there we go. So this came in as fixed. My base is fixed as it should be. And this has 1 degree of freedom, which I know is a rotation. So we'll toggle this off, and I can move this part under the rules of my constraints. And this gives me some nice steps. Hit the button, click the part, it will be glued to the cursor, and then I push escape. So I click the button, I click the part that I wish to move, and you know, it's not moving. That does happen sometimes. Maybe I'll try clicking this, and yeah, sometimes that does happen, and that's okay. But we can actually do dynamic mechanical motion in this assembly. I don't know why sometimes it doesn't seem to work for me, but if I right click on this, I can say transform right here, right? And I can sort of move this, and then I can hit the solve button, which makes sure that all the constraints are reapplied. So I can do a little bit of movement that way. Let's try it again. Yep, still nothing. So this allows us to move under the rule of constraints when it does work, and I think it'll work before the video is over. Let's explore some more options. So I click to add a part, and let's add, how about bar 4? And I again can choose this coincident constraint. I can also choose a parallel constraint, which of course is coincident, except they're not touching. They don't have to touch. They just have to be, the two faces have to be parallel. There you go. So this is our dynamic motion that we've added. Let's try this again with this one. Nothing on this one, but that's okay. I think we're going to get better. So now I've just added so that this face and this face, of course, have to remain parallel. What if I added another reduction in degrees of freedom? I've selected this little point here, and I selected this plane, and I have this option to keep this point on the plane. And that is two constraints working together that really make that the same thing, where these faces have to be touching in parallel, just like the plane on plane that we did on this part have to be. I again can do my axial alignment. Here I can create parallel axis constraints, which keeps two axes parallel, but they don't have to be on top of each other. I think that's kind of explanatory. There you go. So there is where I can use my cursor to simulate mechanical motion. I've had trouble doing that in the past, but it seems like either updates to this have made it easy, or I'm just magically doing something that I didn't know what it was before. Still not much luck with this one though, but at least I got to show you that you really can simulate mechanical motion using your cursor. Likewise, I can also just move the part if I wish without rule of constraints. And then I say OK, and then I reapply the constraints and they snap back to the right spot. Again, I really want this bar to move, but I think when we add more parts, we may be able to see that. So we're going to add some more shapes. How about bar? There we go. So we have bar 3 now. We'll select these two and say, share the same axis. Now, if I wish to establish a certain angle between these faces, I can do that. Right here, create an angled plane constraint. Maybe I want these to be 45 degrees, right? I'll again try to move this guy. There we go. So it takes a little bit, but we certainly can move with our linkage. I actually don't want an angled plane constraint. So if you wish to edit any of these, right, we have our bar 3 here, and we can go to our angled plane and just delete that constraint. Or we, of course, we can. Oh, my mouse has stopped working here. Hold on. There we go. My mouse is about to die. Seriously. As you can tell, I've almost lost my rotate screen. We might have my mouse die on camera, and that would be a problem. So let's hope that that doesn't happen. All right, let's insert another part, bar 2. Let's do the same thing, right? Let's get these axes going. We'll accept that, and we'll put bar 2 right there, same axis. So I've created a problem where the system can't find a solution. So let's get rid of that. And this could, oh, because I've already got, I thought this hole was aligned, this hole's aligned, so I'll choose this hole to align here, same axis. Still can't solve the system. So we'll delete the constraint. We'll select move. We'll do a 180. We'll solve our constraints again. And we're still having problems, right? So we're going to delete one of these, solve again. There we go. We'll say this face and this face will be aligned. So now that these are a little bit closer, we'll see if we can, yep, there we go, add our linkage. I'll click my move under rule of constraints, and you can see how our linkage is working, right? This is starting to look really good. So that's how we do constraints. I might as well make these faces aligned, and I'll flip the direction. Of course, we can't solve that, can't flip the sign, so I guess we'll delete the constraint and choose this face instead. And there's no problem. Let's try to move this guy under rule of constraints, but it doesn't want to cooperate there. All right, so those are basics of constraints. I mean, you have a whole bunch of constraints up here. They're all pretty self-explanatory, right? You can have an axis normal to a plane. You can have an axis plane constraint. You can have parallel. You can have plane coincident, plane angle. What is this? Point and plane. Oh, center of mass. I've never actually used that one. Axial alignment. Circular edge. I mean, they're all doing really similar stuff. And you can check your motion under rules of constraints. So we have some really awesome resources here in FreeCAD. Let's talk about some of the caveats on the A2 Plus Workbench, which is probably my preferred because of how simple it is. I can open up a part, right? I can say, where is it? There it is, edit an imported part. So got my bar 2 highlighted, I can edit my imported part. I can go to my sketch and I can make this from 200 to 150, so I can change the length, and then I can, you know, save and close my part, and then I refresh all my parts, and you can see that length updates in there. So the change reflects in there, and it has kind of thrown off my constraints. And that is a caveat. Usually you can edit these parts and get away with it. Maybe I edited this in a way that it didn't work out. I'll highlight this. Let's just do a little experiment and see what happens. I'm going to say back to 200, close, save, solve. Yeah, it's kind of messed up our constraint system. So that's kind of a problem there. But when you go to edit stuff, that's really when the problems start. So I'm going to hit just Control Z a few times, and that should restore the assembly, right? But if I were to open this up, and if I were to go to Part Design and create a sketch, close, do a cut, right? If I were to add a feature into this, that visually doesn't look all that different. We have all the same faces, we just added a little thing. But I were to save this, and I were to go back to A2 Plus and refresh everything. There's my new part that just refreshed. And I were to solve my constraints. What? No way. So this is like the first, they must have done an update on this, because this is the first time that I've actually had this work, so this is good news. Be careful, though, updating things, because you saw how it broke the last time. So be careful when making updates, because sometimes changing parts can lead to errors. I'm interested to know now, let's do another little experiment. If I update this, go to my model, go to my pocket, and I say through wall, if that changes anything. We'll save, we'll close, we'll rebuild, right? And there we go. I broke something. So adding features can be very dangerous when it comes to having consistent constraints and whatnot. Be very careful and plan to not really make many changes in your assembly, or you'll break, just like how I've broken. So if I try to move something, right, things update weird. So yep, just avoid editing stuff. That is really cool that I could add that little pocket there, though, and initially have it not break. So that's the A2 Plus Workbench. Those are the caveats and how to use it. And I think I've covered everything that I intended to. I hope this was helpful. If it was, please subscribe, and I'll see you in the next video.